Okay, good morning to all. Uh, Today we'll start our next lecture. Today we'll be discussing soil exploration, actually, the subsurface exploration of soil. So before I go to the today's lecture, I'll just briefly review the previous lecture for 5 minutes, maybe, just for a quick review on the previous lecture, what we have done. Okay, so is it visible now, the lecture description slide?
Yes, sir.
Yes, sir.
Okay. So
Yes,
basically,
sir.
last class we try to discuss about some introductory issue from the geotechnical engineering, but mostly the lecture was covered from geotechnical engineering 1 that you just completed in last semester, right? Regarding the introductory part of geotechnical engineering and some soil properties, right? Then we discuss why actually we need to study the geotechnical engineering and its applications, different fields of applications where we apply the geotechnical engineering in knowledge. Okay. Then we just briefly overview the course lectures note with the textbook. So uh, today I find that BM the 8th version book is like more colorful than the 7th version. So maybe I will share the chapters from 8 versions. Okay. So then we try to discuss about some soil properties, like soil properties and some testing issues that that we conducted in last semester. Okay, and from this test experiment or lab experiment, you already know that grain size distribution, plasticity of soil, soil classifications, hydraulic conductivity of soil, this kind of basic properties of soil you already uh, know from the last semester, that it is going to help for this semester. Okay, and we briefly discuss on the grain size distribution. Like for the coarse one, we usually use the sieve analysis, and for the finer one, we use the hydrometer analysis. And we simply discuss why we use a hydrometer for the fine grained soil, and this kind of discussion why it is not possible to do with the sieve analysis. Okay, some size limitations of soils play, and these are some important parameters that we will be needed for the upcoming chapters. So, and the clear understanding of these parameters are needed, like void ratio, poison, porosity, then like unit volume or unit weight in case of like uh, moist condition, dry condition, or saturated conditions. Then we try to discuss about the relative density, right? So the rate change of settlement or other compactions will be depend on this relative density. And also soil classification system, there are few classification systems. So liquid limit is the last limit that after uh, that the soil will be behaving like a liquid, and before that margin it is the plastic stage where you can remold. Actually you can mold your soil, right? Maybe you did the test in geotechnical engineering 1 with this, right? You try to make a shape changing, right, by ruling on a certain board, right, the soil. Have you done this
Yes,
in
sir.
geotechnical engineering 1
Yes, sir.
in,
Yes, sir.
in plastic?
Yes, sir.
Yes, sir.
But by adding water or moisture in a soil, you try to change its shapes, so you check the plasticity range also.
Yes, sir.
Then we discuss about the hydraulic conductivity of soil, like how water is passing through the soil. So there within soil there are some pores, and through these pores the water can pass through, and definitely the direction would be the gravitational directions, because water always go with the gravitational directions, right? And then we discuss about the effective
Sir.
stress. effective stress. Uh, Along with the effective stress, if we add the stress from the water pressure, okay, so that will give you the total stress. Is there anyone that who can explain me what is effective stress that we discussed in the last class?
Yes, sir. Sir, last class
Many
it said
particles
that
and
effective stress is there will be like three particle, and the first upper particle will give the stress on the second lower particle, then they will give the third lower particle. Actually, the go down by down. Stress actually they go one particle to another particle directly.
Yes, it's not like only three things. Just it is like a continuation, like the
Right, sir.
first
contact
particle
surface
surface.
of the particle, how it is transferring the load. Okay,
Yes, sir.
okay, good. Okay, and the compressibility of soil, you can see that it depends on the settlement. Maybe last class I try to give a very brief discussion on here, but here you can you see?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
I think
It,
I can use the highlighter here now. So have a look. This is the foundation upper layer that where it was in, right? So then it settled down here. So but this total portion settled uniformly, right?
right, sir.
So no changes in
Right,
the
sir. Yes,
load transformations, right? The load mechanism doesn't change. But here you can see this
yes, sir.
portion settle this portion settles higher. The settlement of this portion is higher than this side, right? There is no
Right.
settlement, but here is the higher settlement. So that's why it's going to tilt. So maybe in your life you find so many news is like that. Many structures is tilting like that, right?
Yes, sir.
Because they have the higher settlement here, right?
Right.
So that's why they have a tilting force. Okay. If the structure doesn't have enough strength to go along with, what will happen? It will feel some tension force here, right? If it is trying to stay here and it is trying to go down here, right? So there is a tension force. So if the structure doesn't have enough strength on it, so it will give you what? Some crack or fail,
Yes, sir. It will be fair.
right?
Yes, sir. Right, sir.
So so that's why rigidity is important. Here you can see it develops some tension while you have some partial settlement. Okay.
Yes,
So
sir.
here is the another example I can give you in details. That have a look. This is the structure before any sort of settlement, and this one is settling uniformly. No change in the baseline, right?
Yes, sir.
Okay. But here you can see the settlement of these bays is higher than this, right?
Yes, sir.
And
Yes, sir.
settlement of these bays, okay, and these base is almost same, but this base is higher. So what happening
Yes,
here,
sir.
you can see this member is having, or this member is inclined now. Before it was horizontal, right? Before
Yes, sir.
these members were
Yes, sir.
horizontal, but now these members are inclined. So you can see if these members are or these members are inclined, so it will generate two kinds of force. One is the vertical and is the horizontal. So that time this structure has a chance to face the horizontal thrust or horizontal forces, right? You understand? But you
Yes,
design
sir.
you design this one, you will take only vertical. But due to the settlement, it is having horizontal or lateral force. So the load transformation or load transferring mechanism has been changed due to the partial settlement. So that is a dangerous point for the structural integrity. Is that clear now? Yes, no, what?
Yes, sir.
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Okay. And this is the shear strength of soil. Like, you know, if you are applying load, suppose if you are applying this load, okay, so it will transfer. So if it transfer the load, it has an intensity to develop a shear failure on this line. Okay. So I can give you a small example. In your childhood, maybe sometimes you stand in the bank of river, right, where the soil is like collapsing, going to collapse to the pond or going to collapse to the river, right? So if you stand here, suppose if you're
Right,
standing
sir.
here, so what is going to happen? Are you going to have the slicing like that, this portion, only this portion,
The soil will collapse.
only this rectangular?
The whole question will be flat, sir.
Are you going to have the sliding like that?
No, sir. Whole portion.
Please. Okay. So have a look. The soil is not going to fail like this, right? Soil is going to fail like this way, right?
Yes, sir.
So it will fail
It will
like
be
a
flat.
sliding way. Still I'm having the echo. Okay, now it's okay. So soil is going to fail like a sliding way. That is we call shear, right? If the force is developing parallelly, that time we call it shear force. So since soil is going to fail on this region, that would be the failure line of the soil. Do you understand?
Yes, sir.
Okay. And there are some structures as a lateral earth pressure or retaining structures. So have a look. This is a structures. Which one is like which one is like having the load from the earth, right?
Yes, sir.
And this vertical member is resisting. Okay.
Sir.
So similar activities is going on for here. This soil is giving the lateral load here, right? This soil is also giving the lateral load here, and this road is giving the lateral load
Sir.
here. Yes, sir. Now have a look. You can see this is
Okay, sir.
the structures which is having the lateral load, right? And it is resisting the loads from this soil area, right? These kind of structures we will discuss in the maybe 7 and 8 chapters of this. So that is actually the introduction lectures review from the last class. So now we can move to the new lectures. Okay. Okay, now so any confusion from the lecture, that is the previous lecture?
No, sir.
No, sir.
Okay, so today we'll be discussing about the subsurface exploration. So subsurface means what? What is subsurface? Anybody?
Below the
Under the
surface.
surface.
Exactly. So just inside the surface. So subsurface means just below the ground, and
Sir, turn off
exploration
your.
means okay. So subsurface means the below the ground, and exploration means we are going to investigate that soil that where we are going to construct our building or structures. So why actually we need these subsurface explorations? So there are so many reasons. So I think you also know. Just to review some idea, that type and depth of foundation. Suppose you are going to select a, or suppose you are going to construct a structure. So based on the soil parameters and based on the soil strength, you are going to select what kind of foundations you are going to construct. Either it is pile foundations, footing foundations, or mat foundations, whatever it is, right? Based on the soil property or the requirement of your basement. Then you want to know the load bearing capacity of the foundations, like the soil, how much capacity will give. So from that point of view, you can also calculate the bearing capacity of soil, and then you know the foundation capacity, and estimating the probable settlement of structures. So we know that soil layer or soil strata settles with the time, right? Either it is initial stage or a longer period, but it continues its settlement. So that's why you need to know the scenario of the settlements. Is there any difference between the consolidations and compactions?
Yes, sir.
Like initial settlement and consolidations, is there any difference? Anybody
Yes, sir.
from your side?
Yes, sir.
What is this?
Yes, sir.
What is initial settlement and what is
So
consolidation?
there is difference.
What is the difference?
So consolidation is long time settlement.
Yes.
And initial settlement is like compaction, like void throughout only air, not water.
Okay, and it is actually,
But consolidation process.
okay, I add with you, like it's a short process, short term.
Sir,
After
compaction is the mechanical process.
uh-huh.
Yes, sir.
Yes.
Sir, compaction is the mechanical process.
Okay. So actually,
And
what
sir,
what I want to mention in case of these two, that is, one is the fastest, another is the time consuming. So the construction you're going to do, that is not for only 5 years or 10 years. You are going to do for longer periods. Maybe you consider the structure life is 100 years, right? So that's why you need to know the longer scenario. So that's why you need all sort of uh, idea about the settlement. And determine the potential foundation problem. Suppose your soil layer might have some problem, like maybe it is expansive soil, it might be collapsible soil, sanitary landfill. Sometimes you will find decomposite materials into the soil, right? Like biodegradable materials, which has a higher rate of settlement, right? In the longer period, maybe. Suppose you filled your land with a very what is called biodegradable materials. You dump it there and you fill it your land, and after 5-10 years later you find suddenly settlement or higher amount of settlement, which is very dangerous for your structures. So if you do the exploration properly, you can get idea. And determining the location of the water table, this is also important, because water table locations uh, impact the bearing capacity of the soil. And you need to think of the 3 seasons water table, right? Summer, winter, and spring, all the seasons you need to think of, like specifically in the winter, where the water level is it in the winter, and in the monsoon season, right? Monsoon season, the water level rise. Okay. And predicting the lateral earth pressure of the structure, such as retaining walls, sheet piles, bucket, or brace. So basically the lateral earth pressure. So while you need to design some retaining wall or some other uh, retaining structures, so that time you need to know how much pressure is coming from the soil. So otherwise you cannot design the members. Establishing the construction methods for changing subsoil conditions. Suppose the subsoil you have in your project is very weak maybe, so that time you need to think of how to improve it and what are the way you can improve it and what are the easy way to construct the construction of your structures there.
So you mentioned about the water table, but what about buildings near lakes and rivers?
Similar, if the
So
buildings if the buildings is near the lakes and rivers, so you have the impact on the water table. So if you know the water table scenario, so everything you can consider. So if you have the river or lakes near the construction, so your water level would be higher, right?
Yes.
So that time you can
Sir,
adjust.
yes, sir.
So that's why water table, if you consider the water table on this different season, you will get the informations. Okay, so here you can see that overview of the subsurface exploration. In case of subsurface exploration, we classify in three ways, that is the collecting of preliminary informations, reconnaissance, and site investigations. So in case of preliminary investigations, you decide what type of construction are you going to do, right? Actually, what type of structures?
Yes, sir.
Is it steel structures? It is like concrete, or you can plan, okay, what kind of structures you are going to do. And then you go for reconnaissance. Reconnaissance is a kind of defensive word. Usually the military people, whenever they go for any fight or any war, they always look into the enemy's issues and careful about their threats and other issues, right? They closely investigate. So that is kind of the word reconnaissance is coming from this industry. But here reconnaissance, you go for a field trip to the structures, sorry, to the site. Why? Suppose, oh, where is my cursor? Sorry. Okay, so you go for a field trip, okay? Because before going to the field, you don't know what is the scenario of the site topography, groundwater levels, and site vegetations, or if you have any obstacle in the site that which might give you disturbance during the testing. Suppose you decided to do some sort of borehole or some testing, so that time you need to make a borehole. Okay, so you need to make a borehole, you need to collect the samples for testing in laboratories, right? So for that reason, you need to decide different methods. There are some different methods we'll be discussing. So before deciding this method, you need to go to the field to investigate that the methods you are selecting or the techniques you are going to follow will be available or will be suitable to maintain this in this site or maintain the procedure on the site. Maybe you need a electric power supply, maybe electrical connections, but in the site you do not have it. So that time you need to make a backup plan, right? Maybe you're planning for like heavy equipment or machineries to transfer there, but you are not having a proper road and other transportation facility. So how can you go there? Are you getting the concept?
Yes, sir, I get it.
Okay, so that's why you
Yes,
need
sir.
to go for first
yes,
reconnaissance, then you go for site investigations. So is that
sir, we get it.
is that clear, this slide?
Yes, sir.
Yes, sir. Clear.
Okay, so
Yes,
now
sir.
now
Yes,
come
sir.
to the depth of boring lectures. That is how we can decide the depth of boring. So before that, I can show you this picture. Here you can see this is kind of foundations, and this is the depth of up to this depth they consider the boring. Okay, and there also they calculate the stress increased. You can see the stress increased, right? Gradually if they go down and the stress of the soil is increased, right? Okay, and this is the difference in that layer, how much stress is increased.
Yes, sir.
Okay, this is the difference on that layer, how much stress increased with respect to the previous layer. Okay, so now if we want to calculate the depth of a boring, so we need to know this information first, that determine the net increase in effective stress. We can calculate this del sigma prime under a foundations with depth as shown in the figure below. So we just discuss that figure and estimate the variation of the vertical effective stress. Okay, sigma prime. So we can calculate the del sigma prime and sigma prime. Okay, so from these one we can calculate the effective stress variations easily. So after that we can go for depth identifications, that which depth we are going to do. Like first one we consider D1, at which the effective stress increase is equal to, that is the 10% or 1 by 10 of what 1 by 10 of Q. Is that clear? So what is Q? Q is the applied load. Are you getting? If it is total Q, it is the load. If you consider small q, that is the estimated net stress on the foundation. So what is the difference between load and
Yes,
stress?
sir.
What is the difference between load and stress? F is,
Load equals to stress into area.
F is the load, right? And if you consider small q is a stress, so stress equals to force over area. So in case of force, you are having the area and the what? Stress multiplied, right? In case of stress, you have the unit amount, right? That per area, how much load you can apply. So these are similar, right?
Yes, sir.
So this is called isobar. I'm not sure that you have any introduction of this isobar in last chapter, last lecture. Last lecture, I mean the last semester. That isobar, how the load distribution of soil is happening. You can see this line. Wherever you consider the line, it would be 0.1 of Q. So this layer of the soil will consider or will carry 0.1 of Q. That means 10% of the load. So gradually, if you consider this layer is going to take around 9.9 of Q. Okay. So somehow we need to find out this portion, that which depth it is giving you this 0.1 Q. Okay, suppose if you consider this is a depth, this is a jet, right? So this would be one height here, there another height here, not height, depth, right? So every point you have the depth, so you can find the value. So it would be your D, right? You understand or not now?
Yes, sir.
Okay, so this is one way to find out the D1. Another, determine the depth D2 at which this stress ratio, that is the effective stress and the estimated vertical stress ratio is 0.05. So where you find this 0.05, you consider that depth is D2. Okay, so once you have these two depth, you can decide which one is smaller. Okay, you consider
Yes, sir.
the smaller depth, that would be your depth of boring, because inside you don't know how much depth you need to go. Am I right? In the side you don't know how much depth you need to do the boring. Okay, so if you you consider this either D1 or D2 while you do not have any bedrock. If you find bedrock, that time you stop and you need to think of something else. You can go for bedrock boring. So it's around 3 meters. So we will discuss later now. Okay, If there is no bedrock, okay, you stick to the plan. And once you have the smaller diameter, smaller depth, you just add this df. Df is the depth of foundations from the above ground, so that would be the total depth of boring. Okay, here you can see that is your df. Okay, so from you just consider df and plus d, so that would be total d. Is that clear now? Can you see the
Yes, sir.
can you see the
Sir,
slide?
first step.
Okay, so if the preceding rules are used, the depth of boring, okay, for a building with a width that is 30 meter, okay, so if you consider a building which is having a width of 30 meter, okay, so what would be the usual dimension or the length of boring? That is, this is suggesting. So Mr. Shore and Shores, they studied and they are suggesting that if it is number of stories 1, you go around 3.5 meter, gradually up to 5 story you can go up to 24 meters. But these are not fixed value, these are suggestions. If you find your satisfactory soil layer, okay, you stop. If you don't, you go more. You understand?
Yes, sir.
Okay, so if you think of your structures, that is a steel or narrow concrete building, if you're having like steel and narrow concrete building, so you use this formula where db is the depth you are looking for, and s is the number of stories, okay, and a is the empirical value, which would be 3 if you are in meter. Like if you consider your values in meter, so you consider 3, or if it is in feet, you consider how much? You consider 10, no problem, right? If you want to find out db in feet, right? So that time you
Yes, sir.
consider a is 10, no problem. For heavy steel or white concrete building, similar way, that time you consider the coefficient as empirical value as a b, so only b is changing for heavy steel and wider, so that time for b you consider 6, just double actually, and for feet you consider 20, in meter you consider 6.
Yes, sir.
Sir, s to the power 0.7.
Yes, this is the number of story, s is the number of story. If it is 5 story, you put the value of 5 and to the power of 0.7.
Yes, sir.
Okay, so when deep excavation are anticipated, like sometimes you find that the depth you calculated, okay, it's very fine, but sometimes the samples or the soil layer you are getting, this is very uh, unpredictable, or you're not happy with the result. You want to go for more testing, you want to go more depth, right? So that time you go at least 1.5 times of the depth. Okay,
Yes, sir.
and in case of bedrock, that I said I will discuss it later, so if you encounter bedrock, so usually you go 3 meter, right? Because the bedrock is the ultimate state of soil, is a very high in bearing capacity. So usually if you just consider 3 meter of testing is good enough. But if you find the bedrock is having some problem, or some weather bedrock, that is not permanently bedrock from the uh, molten magma or other formations, is weathered one, you might have some crack, you might have some issues, right, with the uh, rocks, so that time you can go for more depth of boring until you find a satisfactory result. Okay, so actually this is the last slide. I'll take 1 minute, 1 or 2 minutes on it. So number of boring you needed. So actually this is a very common question, sir, how many boring I do in a project, or how many boreholes I need to consider for soil test, right? So there are some guideline, but these are not fixed one. You can increase, you can decrease based on it. But if you have uniform, you can follow this. Okay, if you have uniform soil, you can follow this guideline. But it is if it is an ununiform, non-homogeneous soil, you need to do more. For uniform, you can do fewer boreholes, or for non-homogeneous, you need to go for more. So they are saying that one boring at each corner of the building and one boring at the center of the building should be provided. So corner and the center must be covered, and after that you can decide the spacing. If it is multi-storied, you can consider 10 to 30 meter spacing maximum. If it is one-story industrial plant, like very higher area, so you can consider 20 to 60. Like sometimes you will find very long project. Even if it is highway, you can go 250 to 500, right? So these are some examples. And lastly, this is an important message for the engineers, that you should consider this soil testing in the cost, because this is just only 0.1 to 0.5%, not 1% or not 5%. This is just only 0.1 to 0.5% of the cost of your structures, right? It's a very small amount of cost that you're doing or you're spending for the exploration. So that's why it's very important. It might save your whole project if you do this. Okay, so next class we'll start
Yes,
from
sir.
the
Sir,
like methods of boring of soil. So since time's up, I will conclude here. Uh, do you have any confusion or question on this?
no, sir.
No.
No, sir.
No, sir.
No, sir. No, sir.
Okay, sir.
So one question about,
Yes, love you.
sir, say that if, like, usually in Bangladesh, some areas, like what they do is they slowly fill the land with soil. Sometimes the soil isn't uniform, like different types of soil. Sometimes they put construction materials, sometimes they take soil from other areas. So when constructing above that soil, is there any difference compared to how we do it normally?
Uh, Basically, if they can notice that there is a newly filled materials, they usually skip. They usually do not consider this layer for the foundation. They consider more deeper layer. Suppose you may fill the what is called land, maybe 5 feet or 10 feet of the ground. So that time engineers usually do not consider that layer, because that layer is not uh, uniform, because it gives the very unpredictable what is called unpredictable behavior of soil until it is settled down for like 10 to 15 years, something like that. And if
So
engineers know that you like you fill the project with the like some city corporations waste materials or something like that, that time they will definitely go for deeper exploration of soil.